All right, today we are reviewing chapter 20, which is on inference for linear regression. Okay, so what this chapter is all about is maybe you believe that two variables have a linear relationship. So you could find a linear regression line to model that relationship, to get an equation that would allow you to make predictions about, for different inputs and outputs. But if you don't have the entire population for both variables, x and y, you may be sampling from a population and finding a sample regression line using procedures that we've already learned in chapters 7, 8, 9. Mainly, we would look at the slope as a good indicator of a linear relationship. If there is a relationship, the slope for the population regression line should be probably 0. Okay, so when we're using a sample to represent a population, then inference procedures do come into play. And so most of the questions that we are focusing on for review purposes, because it's most likely what will be on the AP exam, are those questions about whether or not a linear model is appropriate and what that slope might be. Okay, when we did the homework, we did see some problems where we were doing different kinds of inference, like we were creating prediction intervals, like what's a particular plausible range of y values for a given x for a sample or for an individual. But that is very unlikely to appear on the AP exam. Okay, so you can kind of not worry about that so much. We also talked about that you could do inference for the y-intercept, and a lot of those computer output tables have that information there as well, but you shouldn't be asked anything about that. The only scenario when either of those might come up is on question 6 on the AP exam. That, on the free response part, that question is always supposed to have something new, something that is not technically part of the AP syllabus, but uses ideas that you have already learned kind of in a new context. So in theory, you might see something like that there, but it would be very unlikely. Okay, so just like all of our inference procedures, whether we're doing inference for means or inference for proportions or inference for counts, chi-squared, we do have conditions that we need to check to make sure that the procedures are appropriate. Okay, and so we learned the acronym LINER, L-I-N-E-R, to help us remember what conditions we need to check in chapter 27 for linear regression inference. So the L in LINER stands for linear, and to check that, you should check the scatter plot for a straight relationship, and you should check the residual plot for no patterns. And so to prove that you've checked this condition, you would make a small sketch of both and a brief comment on both. Just saying yes is not good enough. And again, when you're checking conditions, you don't need to have scale or label your axes, although it would be appropriate to say which one's which. This is the residual plot, this is the scatter plot. Okay. I stands for independent, and so to check that, really what you're checking is 10% condition, making sure that the sample is no more than 10% of the population, and that the procedures or the data involved, there's no reason to believe that they're dependent. Okay. The N stands for normal or nearly normal, and so what you're checking here is if the residuals are approximately normal. Okay, and so the way you would do that, which we'll look at in a minute, is you need to take that resid list and put it in a named list in your calculator, like L3 or something like that, and then look at the histogram or possibly the normal probability plot. Usually we just use the histogram, and make sure we don't have any strong skew to it. Okay. E is the equal variance condition, and really you check this one at the same time you're checking linear, because you're looking at the residual plot, the one that has the each residual plotted against x, so the scatter plot of the residuals, when you're checking this. So you would check this one at the same time when you're looking to see if the residual plot has patterns. So what you're looking here is that there should be roughly equal scatter of the residuals above and below the 0 residual line, and that you're not seeing obvious fanning where the residuals start really small and then they get really big, or vice versa. Okay. And then the last condition, R, stands for random sampling or random assignment, which you know how to check. Hopefully it would be stated in the problem, otherwise you would need to say we're assuming that this condition is met. Okay? Now if it's on a multiple choice question, then they might ask you, to check conditions or something like that and have this one not be met. But if it is on a free response question, you can expect that the conditions most likely will be met, but you will have to show that they are. Okay, so we learned how to do two different inference procedures that are likely to be covered on the AP exam, and that is the confidence interval for slope and the hypothesis test for slope. So let's get some data and look at how we do all of this stuff here. So, okay, there it's back. All right, so we'll turn on the calculator, go to stat, I didn't like it. Stat, edit. Let's see what I have in my list here. 1, 2, 3, 4, 5, 6. I don't know if I want to use the same data. This is a little boring, so I'll put something else in here. Make up some other numbers. About 5, 11, 16. Oh, it did not like that. 5, enter. 11, enter. 16, enter. 20. Let's do 22 and 36. Okay, so there's some data, and we can go. Now, when you're doing the stat test, it will do the linear regression for you at the same time, so you can avoid having to do it over and over and over again. Okay, so I'm going to go down and I'm going to look for the lin-reg t-test. I'm going to go ahead and do the hypothesis test first. So keep scrolling down until you find it. It's pretty far down. There's a lin-reg t-test and the lin-reg t-interval. So lin-reg t-test, make sure you identify the lists where the data is. Now you have to choose your alternates here. Beta is the Greek for the hypothesized slope, and rho is the hypothesized R, correlation coefficient. And basically you're kind of testing both at once because they really mean about the same thing. I just want to know if this data is linear or not, or if it's appropriate to use a linear model for it. So I'm going to choose a not equal alternate. And I'm going to tell it to store the regression equation in Y1 for me. And then we go to calculate. Okay, so I have a t-value of 7.37, a p-value of 0.002, basically, degrees of freedom 4. So I should report this on the state plan do part of my hypothesis test. And if I keep scrolling down, the equation is given here as well. So I can see that my y-intercept is negative 0.87, okay? And the slope is 5.49. And this is the standard deviation of the residuals. So a typical residual is about 3.1, okay? R squared is 0.93, not terrible. R equals 0.97, that's pretty good, okay? Now, according to the lin-reg t-test, with this p-value this small, I would probably be rejecting the null and concluding that the slope is not 0. Therefore, a linear model is appropriate to model this data. And when I would write down my model, of course, I'd remember to do so in context. What does each of these stand for? What is the y? Like maybe it's age hat equals negative 8.7 or negative 0.87 plus 5.48 times year, or whatever the variables are. Okay, so now that we've done all that, I ought to go look at the graph because I need to check the conditions after the fact, basically. So I need to change this to list 2 and zoom 9. Oh, I hate when it does that. Zoom 9. So it looks really good down here. I'm not so sure about up here. Looks okay for the most part. Let's check the resid list. Now remember, the resid list is not the right resid list until you have done the linear regression or the test. because it'll be a resid from a previous problem. So always make sure you do the linear regression first. Okay, so resid, and then zoom 9. And so, is that a pattern? Well, when I only have 6 points, it's pretty hard to tell. I've got 3 above, 2 below, 1 above. I don't know that that's enough to say the data is curved when I only have 6 points. But it could be that a curved model would actually fit this a little better. But I don't need to worry about that in chapter 27. That'll come up in chapter 10. I can also do a confidence interval for the slope. So that would be the linreg t interval. Linreg t int. And you can set the appropriate level of confidence. Again, it can do the regression equation for you at the same time, so you don't have to do linreg under calc and then come here and do the test. You can just do it all at once. And so here is the interval for slope. So it's saying we are 95% confident that the true mean slope for whatever this is about, okay, is between 3.42 and 7.55. When you report this, do report the units. You know, slope has units, and that will help explain, you know, what you're talking about. So maybe this is age 3.42 to 7.55 feet per mile or something. You know, I don't know what it's about because I just made up the data. But make sure you include context there. Some other things we might want to look at. We did not finish checking our conditions, right? We never checked the residual plot for the histogram for the residuals. So let's go put that in list 3. So I'm going to change this to the resid list. Here we go. And enter. Okay, so those are all the residuals. And I can go into my stat plot and change the type to histogram. And zoom 9. Well, is that sort of normal or is it skewed? Well, with 6 points, it is very hard to tell. It could be slightly right skewed, but with 6 points, I probably really don't have enough information to tell. Okay, so this is a little bit concerning. It looks a little bit right skewed to me, but there's so few data, again, it is a little hard to tell. Okay, so that was checking the N. We've talked about checking the L. Oh, we didn't really talk about equal variance, so maybe let's go and look at that one again. I'll go put the resid, change it back to this, and put the resid list in there. There it is. So zoom 9. Gotta quit first again. I don't know why it doesn't. Zoom 9. And so equal variance, we're looking for approximately equal number of points above and below. Well, 4 to 2, pretty close. And approximately equal distance above and below. They start out smaller and get a little bigger. Maybe that's some fanning, but with 6 points, again, it's hard to tell. You know, this one's kind of balances out that one. This one almost balances out that one, and these are both above. So it's pretty close. If I had a lot more data and I were still seeing this, you know, gets farther away as time goes on pattern, then I would be a little concerned. With 6 points, I'm probably not that concerned. Okay, so that's the majority of what we did in chapter 27. Just make sure that you're not being careless in your write-up about checking conditions and stuff like that. If you have to report an interval, you know, from the, calculator, from computer input, remember that this is how you calculate the interval. It's the hypothesized slope plus or minus a t star times the standard deviation of the residuals divided by, I think these formulas are provided on your formula sheet for the AP exam, which you should familiarize yourself with so you know what's on there and what you're going to have to remember and what you're not going to have to remember. Degrees of freedom is n minus 2, okay? And if we look at the hypothesis test, remember to use, you know, the Greek parameter notation, and that you can use the t-table to figure out the degrees of freedom in your test statistic. It's usually reported in the computer output though, okay? So that concludes our review of chapter 27.